So guys, welcome to our channel once again. In today's video on our WAEC Physics System Revision series, we have here these 10 WAEC repeated questions to answer on the topic simple AC circuits. So in short, stay till the end of this video as this is a very important one. Let's go ahead and start with this question here. It says, the diagram below illustrates an AC source of 50 volts root mean square, 100 over pi hertz, connected in series with an inductor of inductance L and a resistor of resistance R. The current in the circuit is 2 amps and the potential difference across L and R are 30 volts and 40 volts respectively. Use this information to answer the questions below. Calculate the average power dissipated in the circuit. Alright, so guys, for the average power dissipated in this circuit, that's going to be I squared R. So power is I squared R, where I squared is 2 squared. From here, from the diagram here, you can see the currents. So when you square the current, that's 2 squared, that's 4. Then times the resistance. So guys, so since the voltage across the resistance here is 40 volts, we can actually calculate for the resistance by the formula V is equal to IR, where R becomes V over I. So 40 volts here, which is the potential difference, over the current, which is 2 amps. So that will give us 20 volts. So if you multiply 20 volts by 4, that will give us 80 watts. So option B is the answer to this question. Let's go ahead and consider the next question, guys. Alright, so the next question here is question number 2. It says, the diagram below illustrates an AC source of 50 volts root mean square, 100 over pi hertz, connected in series with an inductor of inductance L. Just the same information we have previously. So, but then here it says calculate the power factor of the circuit. So here, in order for us to calculate for the power factor, we're going to use the formula power factor, which is cos theta is equal to R over Z, where we have that R is the resistance here, and then for Z we can actually calculate for the Z using the square root of R squared plus X squared. So but then guys, for R, first of all, we've calculated R to be 20 using the potential difference across the circuit, across the resistance in the circuit and the current here. That's 40 over 2, and that's 20. So R is already 20. So the next thing to calculate is for Z. So guys, in order for us to get Z here, we're going to have the square root of R squared plus X squared. Actually, it's X sub L squared. So that's the inductive reactance here. So if we go ahead and put the values here, actually R squared is 20 squared, and then X squared or XL squared is the square of the inductive reactance here. In order for us to get the inductive reactance, that will be the voltage across the inductor over the current here. So that will be 30 over 2, and that's 15. So in this case, we'll have 20 squared plus 15 squared, all in square roots. So that's square root of 625, and that's 25. So now that we have z to be 25, we can go ahead and calculate the cos theta, which is the power factor, and that's equal to 20 over 25. So that's 0.8, and that's option C here, guys. So let's go ahead and consider the next question. So guys, the next question we have here is question number 3. It says, in a RC circuit, A, root mean square voltage lags root mean square current by 90 degrees. B, root mean square current lags root mean square voltage by 60 degrees. C, root mean square current leads root mean square voltage by 60 degrees. D, root mean square voltage leads root mean square current by 90 degrees. Alright, so guys, the answer to this question is option D here. Root mean square voltage leads root mean square current by 90 degrees in an RC circuit, that's resistor capacitor circuit, and that's because of the phase shift that is caused by the capacitor in this circuit. And that's it for this question. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 4. It says, in an electric circuit, an inductor of inductance 0.5H and resistance 50 ohms is connected to an alternating current source of frequency 60 Hz. Calculate the impedance of this circuit. So guys, the impedance here is Z, and Z is equal to square root of R squared plus X squared, so actually XL squared. So in this case, R squared is the square of the resistance, which is the square of the 50 here. Then S squared is the square of the reactance, so that's the inductive reactance here, XL. So in this case, we are going to have the inductive reactance with the formula 2 pi FL. So X sub L is equal to 2 pi FL. So that's 2 times pi times the frequency, which is 60 Hz, times the inductor, which is 0.5. So guys, when we calculate this, we'll have 188.4. So in that case, Z is equal to square root of 60 squared plus 188.4 squared. So guys, when we go ahead and calculate this, we are going to have 195 per ohms. And that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 5. It says, one difference between a reactance and the resistance in an alternating current circuit is A, resistance is larger than reactance. B, energy is stored in resistance but not in a reactance. C, the current in a reactance is lower in the resistance. And D, energy is not dissipated in a reactance. So guys, the answer to this question is option D here. Energy is not dissipated in a reactance. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 6. It says, an inductor of inductance 1.0 H is connected in series with a capacitor of capacitance 2.0 microfarads in an AC circuit. Calculate the value of frequency that will make the circuit resonate. So guys, the frequency here of this circuit will be F0 is equal to 1 over 2 pi L square root of LC. So that's 1 over 2 pi root LC. So if we want to calculate for this, Then we're going to plug in the values here. So that's F naught is equal to 1 over 2 times 3.142 times square root of 1 times 20 times 10 to the power of negative 6. So guys, if we go ahead and calculate this together, we're going to have that the frequency F naught is 112.5 Hertz. And that's it for this question, option C. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 7. It says, an ammeter connected to an AC circuit records 5.5 amps. The peak current in the circuit is A 7.8 amps, B 3.9 amps, C 3.5 amps, D 7.1 amps. So guys, this is a very simple one. All we just need to do is to recall that the root mean square current times square root of 2 is equal to the peak current. So we're going to have that the peak current will be equal to the root mean square current, which is 5.5 amps, then times root 2. So this will give us 7.8 amps, and that's option A here, guys. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question here is question number 8. It says, the diagram above is an illustration of a circuit. Calculate the reactance of the capacitor. So guys, that's the capacitive reactance here. So the reactance of the capacitor here will be XC. So guys, that will be 1 over 2 pi FC. So here, if we impute the values for all the variables here, XC is equal to 1 over 2 times pi times the frequency is actually 500 over pi, then times the capacitance here, which is 5 microfarads. So in this case, pi can cancel out, and then we'll have this to be 1 over 2 times 500 times 5 microfarads. 5 microfarads is 5 times 10 to the power of negative 6. So guys, we can take this 10 to the power of negative 6 up and it becomes positive. So in that case, we'll have the capacitive reactance X in here to be equal to 10 to the power of 6 over 2 times 500 times 5. So guys, that's 200 ohms here, and that's option C. So let's go ahead and consider the next question, guys. So the next question we have here is question number 9, and it says, an alternative current supply is connected to an electric lamp which lights with the same brightness as it does with a direct current source of 6 volts EMF. The peak potential difference of the AC supply is, alright, so guys, we're going to also recall that the peak voltage is equal to the root mean square voltage times square root of 2. So in this case, the root mean square voltage is 6 volts. So we multiply 6 volts by root 2. That will give us 8.5 volts, and that's option B here. So let's go ahead and consider the next and last question, guys. So guys, the next question and the last here says, an alternating voltage with a frequency of 50 Hz has a period of, alright, so guys, in order to find the alternating voltage period here, the voltage period is going to be 1 over the frequency, which is 1/50, and that's 0.02 seconds. So that's option C here, guys. Option C is the answer to this question, and that's it here. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question in the comment section below, and we'll be sure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community, where we'll post major updates on WAEC examination. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.